to do some checkpoint exercises on each of these examples. I think it's helpful to be able to do some of these exercises now and part of the lecture, just to prepare you for the homework and making sure that you understand the examples. So I'm going to write these checkpoint exercises down and work them out for you. But what I encourage you to do is to stop the video and work them out for yourself, and then check them out. Okay. All right, so let's do the first one. 2 to the 4x equals 32 to the x minus 1. All right, so we want to use this one-to-one property. B to the x equals b to the y. Okay, that's my hint for you. All right, pause it and see if you can work this out yourself. And then come back and then see what I did. All right, if you correctly surmised that you need to have these written with the same base to use this property, you'd be correct. And I know that I can write 32 as 2 to the 5th power to the x minus 1. So now I'm going to be multiplying these exponents. So I get 2 to the 4x equals 2 to the 5x minus 5. Okay, now that these are both the same base, I can set their exponents equal to each other and, use algebra and just solve. So if I do minus 5x minus 5x, I end up with negative x equals negative 5. So in other words, x equals 5. And of course, ideally you would go back and you would just double check it by putting 5 in here and making sure that it works out. Okay, so let's move on to
Sorry, I am having trouble playing the music.
Okay, Alexa decided to come on all of a sudden. It's just really weird. Alexa, cancel. Okay, now let's do an extra example 2. So this is going to be 4x equals 15. All right, so what would be the easiest way to solve this? Well, I think it would be easy to use inverse properties. So to take the logarithm of both sides. Now, which base do I want to use? Well, I think I'm going to use base 4 since that's the base of this exponent. So I'm going to say log base 4 of 4 to the x equals log base 4 of 15. All right, so on the left here, I hope you paused earlier. Okay, x equals log base 4 of 15. And I'm going to use my change of base formula to actually crunch that number out. So I'm going to use the common log. I'm going to say log of 15 divided by log of 4. And when you put that in your calculator, I'm hoping that works out here. Log of 15 divided by log of 4. And I get around 1.95. Yes, that's around 1.95. Okay, now let's go on to example 3, which is just a little bit more. This is an extra example 3. All right, so 5x plus 2 plus 3 equals 25. Okay, so we're going to solve that. First thing we're going to do, we're going to subtract the 3, I mean, your instincts as far as isolating the variable, are going to be the same. This is 22. All right, now what do I do? Well, here it is. I've got this exponential, this base 5. So I'm going to take the logarithm, base 5, of 5x plus 2, and I'm going to take a logarithm base 5 of the other side. There it is. So now I have x plus 2 equals log base 5 of 22. And then so x is going to equal log base 5 of 22 minus 2. And then you could use your change of base formula in here to figure out what that is. So that's going to be x equals, you could say log of 22. This is now going to be base 10. And then log of 5 minus 2. And if you crunch that out, crunch the numbers there, you're going to get log of 22 divided by log of 5. And then I'm going to subtract 2 from that. and I'm going to end up with a negative, this ends up being a negative 0.079. Okay. All right, so that's the first three examples that you can use. I think I can do another one here. Okay. All right, now all right, extra example 5. I'm just going to skip over that. The other one's the word problem, so I don't think you need that so much. Okay, so this is extra example 5. All right, it says solve this. Log base 4 of x plus 3 equals log base 4 of 8x plus 17. Okay, this one's really easy. This is, yeah, I mean, if you want to pause it and work it, go ahead and do that. Otherwise, remember that log base b of x, if that equals log base b of y, that you can use the 1-to-1 property and just assign the arguments equal to each other. So I can do that here. So x plus 3 equals 8x plus 17. So subtract 17, subtract 17, and then I'm going to subtract x, and I end up with negative 14 equals 7x. So x is going to equal negative 2. All right, so that's extra example 5. Okay, and then I think I just got one more here. Okay, next one. This is extra example 6. All right, log base 4 of x plus 3 equals 2. All right, this is going to be one of these ones where you're going to want to exponentiate. Okay, so pause the thing and pause this video and come back. All right, if you're back, we are exponentiating for, we get log base 4 of x plus 3, and I'm going to exponentiate over here. I'm using inverse properties here, so I release the exponent, so it's x plus 3 equals 16. Subtract 3 from both sides and get x equals 13. Okay, and okay, one more example and then we're done. I'm going to do an extra example 7. Okay. All right, log base 2 of x plus log base 2 of x plus 7. Oh, I'm sorry, not plus 7, it's minus 7. Equals 3. All right. All right, so the first thing you're going to want to do, okay, pause it, okay, and then if you need some more hints, then keep going. First thing you're going to want to do is you're going to want to condense, okay? And so you're going to bring this together using your logarithm properties from the section before. This becomes the product of these two equals 3. All right, so in other words, this is log base 2 of x squared minus 7x equals 3. All right, now that you have everything nice and condensed, you can exponentiate. So what's your base going to be? Well, it's going to be the base of this logarithm. So it's going to be base 2. So it's 2 to the log base 2 of this whole thing equals 2 for your base, and then 3 is the exponent here. So what do you get here? You're going to get x squared minus 7x equals 3. And now you're going to have x squared minus 7x minus 3 equals 0. And what is this going to end up being? This looks like it's kind of nasty. Is that right? Um, how is that going to work? X squared minus 7x, right? Minus 7x. Okay, so I'm looking at factors of -3 that combine into -7. I am not sure. This says that the answer is 8. I'm not sure. And this is like this is late at night. Oh, I know what I did wrong. No, that's not right. That is right. It's 2 to the third. Okay, well, they're saying the answer is 8. I'm going to need to think about that, and I don't want to redo this video. So let me think about it for a moment, and because I'm like thinking this doesn't factor nicely, it's going to have to be, but I may just be tired at this point. So let me just end here. They said that the answer is 8, but I don't believe them. And I'm trying to see, did I write this wrong? Okay. All right. I don't know. I'll be back. Okay. Bye.